Okay, so our plan for today, we are going to go ahead and take care of the last focus activity for the first set. You'll have the opportunity to turn this in at the end of class, or tomorrow is when I'm officially going to be looking for them. When you come in, there'll be a little note up on the front board telling you to go ahead and turn those in, and I'll definitely mention it a few times. But the other aspect of today is I just want to continue to practice problems from the current lesson. Tomorrow, we're going to go ahead and talk about the unit circle, and then I'll probably go ahead and talk about the CFA that we had yesterday. But what's the big item coming up on Monday? That's your exam. Okay, so this got 9 questions, and it covers the past 3 lessons. The current one we're on, arc length and circular motion. Then we got right triangle trig, and we've got angles and their measures. Okay, please remember, okay, if you're looking to retake this test, but not that that's going to be needed because everybody's going to do fantastic, right? Of course. But if you find yourself in that predicament, remember you have to have the assignments done before or by the time you retake. All right. So what do we need to study in order to be successful? Well, if you look over at the website, okay, posting for next week, Monday the 14th through Friday the 18th. Number 2 right here, I've given you a whole list of what you need to be able to do on that test. You got a couple of problems very similar to your CFA quiz yesterday. You'll have to convert radians to degrees and back again. You'll have a couple of word problems like we have been looking at. You remember the one where we had the 2 triangles with the sightseer looking down into the canyon? Okay, you got a problem like that. And then it finishes up with linear and angular velocity, which we are talking about today as well. So if you have any questions, please let me know. You are going to be allowed to use your notes, but please take the time to study if you've not already started doing that. Okay, perfect time to start tonight. All right, that's all I've got. So let's take a look at our focus activity. Thank you, Natalia. Excuse me. All right, so given the function f of x shown below, determine the algebraic representation for f of x, find its inverse, and any domain restrictions applicable on f of x when determining the inverse function. Okay, well, before we even go ahead and find the inverse function, if there is one right now, let's go ahead and take a look at my graph. We definitely have a quadratic. Well, will the inverse be a function? No. Okay, how do I know that? The horizontal line test. It fails the horizontal line test, which tells me this function is not, what do we say? 1-to-1. Okay, so that tells me we are going to need restrictions in order to have an inverse function. Would everybody agree? So if I'm looking at my answers, only one of them says no restrictions, so I automatically know f's got to be out. Okay, so why don't we go ahead, let's go ahead and determine what the function is that represents this graph. Then we'll start talking about the restrictions, we'll find the inverse and everything else. Now, I would probably go ahead and use vertex form. Does anybody remember what that is? It's f of x equals, does anybody remember the general form? Right now I'm not looking for the specific one we have here. What represents the scale factor? What variable? A. And then it's going to be x minus what squared? H, and then plus k. Remember, vertex form is using the vertex of the parabola h comma k. All right, so I'll go ahead and tell you in this one that there's no dilation, so the scale factor is just 1. Okay, it's just the normal quadratic parent slid across your coordinate plane here. So what is the vertex of this graph? Okay, it is -3 and then +2, right? So that's my h and that's my k. So why don't we go ahead and plug that in here? So what would f of x equal? Hey, thank you. Okay, Jordan D. Okay. Let's go in just a little bit, give you opportunity to see these, and then let you go. Okay, so what was it? F of x equals, what would I say? X what? X plus 3. If I plug in, if I replace h with a -3, see you're subtracting a negative, so that's why we have a positive, squared, and then what? +2. So it looks like the entire graph was shifted 3 left and 2 up. Okay, so there's the function. Okay. So based on this, we can already tell G is out. Why? Because it says f of x equals x minus 3 squared. Okay, so right there, we've got a 1 in 2 shot as compared to a 1 in 4. Okay, but now let's talk about the restrictions. Because if I go ahead and find the inverse right now, he's not going to be an inverse function. He's going to be an inverse relation. So we've seen problems like this before. What would I need to do to make him one-to-one? I'd have to restrict him. Basically, I would have to cut one half of this graph off horizontally. Okay. Now, does it matter if I restrict it to the left side or to the right side, basically less than -3 or greater than -3? It ultimately doesn't matter. Now, graphically it will, but here, let's look at the restrictions provided to me. What do you think, H or J? Yeah, definitely H is what I need. That -3 is on the line of symmetry. So it says restricting it all x greater than or equal to -3. So that means I'm cutting the left half of this off. So now would he pass the horizontal line test? Yes. I mean, we don't even need to find the inverse function. We already know because of the restriction, the answer has to be H. Okay. If I restricted it to and everything greater than that, it's still not going to pass the horizontal line test. But just for, practice, let's go ahead and find the inverse. So I know this is my function. How do I find the inverse? Does anybody remember? Switch what? The x and the y. So y equals will become x equals. And instead of x plus 3 squared, I'm going to say y plus 3 squared and then plus 2. Okay. And then now we just need to solve for y. So what would I do? What's first? Okay, what's the first term I need to move? 2. All right, so I'm going to subtract it over. X minus 2 is equal to y plus 3 squared. Now what? Square root. Okay. Now, this is, really important. Typically, when we're solving algebraically and we take an even root, we want to go ahead and put a plus minus in front. We don't want to do that here. Remember, we had to restrict the original graph to make this inverse a function. Okay, so basically, I started with half a parabola, so I need to finish with that half a parabola. All right, so I'm going to say the square root of x minus 2 is equal to y plus 3. And then what's my final step? Square root of x minus 2 minus 3 is equal to y. Now, I can go ahead and replace that y with the inverse notation because I made sure that this inverse was going to be a function. Okay. And does that actually match the answer we got in H? Yeah. Okay. In fact, let me go ahead and sketch it. Okay. We could either go ahead and use the transformations here, or we could probably do this. What's the main idea behind inverses? What do you do with the x's and the y's? You switch them, right? So if this vertex was at -3, 2, then what's that inverted point look like? 2, -3. There you go. And you notice we have a positive square root here, so it's probably going to look like that. See, it was shifted 2 to the right and 3 down. Okay. What's the line of symmetry for inverses anyway? Okay. Y equals x. It's that linear parent. So if I were to fold along that line, would the two parts come together perfectly? Okay, remembering that I cut the left side of that parabola off. Okay, so there we go. Any questions? How are we doing? Okay, well, for number 2, I'm going to turn it over to Mr. Yacht. There you go, sir.
Sorry about that. All right, so we got a retail salesperson earns 4% commission for sales over $750 per week, plus their weekly salary of $480, assuming enough merchandise sold to earn commission. Which of the following sets of functions in composite function represents the weekly commission earned? So we're going to have 2 equations. You can tell by looking at the answer choices or by the fact that it says the composite of functions in the question. So first, he earns 4% over how much he makes over 750. So what can one of our equations be? They don't like me as much as they like you. Sorry? Okay. Why is it x minus 750 and not 750 minus x? The x is going to be greater. Yeah. Because we don't want 750 minus x, we don't want that negative difference. And then, so what would the other equation be? Yeah. 0, 4x. So we can see in the answer choices, we also have a 0.4x, and that would be 40% commission. So we know that we can get rid of that one off the bat. And then also, since we have x minus 750, you can get rid of f as well. So we got 2 left. The only difference here is how the composition of functions is set up. Which way would we want to set up our composition of functions? G of f of x. Why would we want that and not f of g of x?
I mean, what you're earning over the commission is the input for what you're getting commission out of.
Yeah, he's saying that this 4% applies to the difference. It doesn't apply to this 750 at all. Now, where does this 480 work in? It's everything. Yeah, it's just irrelevant, just information. So, and making sure you read the question completely. See, I can show that like the other composition doesn't work. If you're going to do f g of x, you'd have to do it over the 750 plus whatever difference you made, and then whenever you get to this, you'd have to subtract 750. But if you were to do this, you'd have to subtract 750. That's like times that 4%, and since that's not in the equation, it doesn't really work out. So you'll end up with g of f of x. So answer choice G. That's what we get. Does that make sense? Lose anyone? All right.
Okay. All right. Let's see what we got. Thanks, sir. Okay. Well, we will have the opportunity to turn this in at the end of class today if you want to. Otherwise, tomorrow is when I'm officially going to be looking for those, as I said. But now we have a choice to make. We can either do one of two things. We did not finish every one of those problems that I was speaking about earlier in the week. We could continue to finish up some of these, or we could take the rest of the time to look at problems off the assignment. What would you guys prefer to do? Assignment. I kind of figured that's going to be the popular choice today. All right. So let's begin. Which problem should we start with? And let's hold off on 12 for just a minute. Because, is it time to go? Yeah, go ahead and run with your pass. Okay. All right, so what are we going to start with? Or do we feel completely confident with the assignment? Okay. All right, Philip. The last 3 questions. Okay. So 11, 12, and 13. Besides 12, which do you place the most importance on? 11. Okay. So is it okay if we start with 11? Okay. Well, let's see here. It says Jacksonville, Florida is due south of Charleston, West Virginia. Find the distance between the two cities if Charleston is located at 38 degrees 21, what does that mean? Minutes, okay. North latitude, and Jacksonville is 30 degrees 20 minutes north latitude. Assume the radius of the Earth is 3,960 miles. Okay. So here's the thing. I've got a cross section of the Earth here. And again, I always like to go ahead and draw a sketch of what we have. So 3,960 miles. Okay. So the thing is, remember, I've said before that the Earth isn't a perfect sphere, but realistically, if we were going to go ahead and try to find the distance between 2 points on the surface of the Earth, it's not going to be a straight line. It's going to be an arc. Okay, exactly what we've been talking about in this lesson. So these 2 angles here represent the cities. So we know that Jacksonville is due south of Charleston. And Charleston's located at 38 degrees 21 minutes. And we know that Jacksonville is at 30 degrees 20 minutes. Okay. So what was the formula for the arc length? What does S equal? There we go. So the arc length S is equal to the radius times theta. The only thing theta, it has to be in what? Yeah, it's got to be in radians. So that's what I'm trying to find here. I want to know the arc length created in this diagram, essentially the distance between the 2 cities. Okay. Well, how can I find that angle theta? Because we already got the radius. Subtract. Okay. So I'm going to take 38 degrees 21 minutes and subtract the 30 degrees 20 minutes. So let's see here. I'm going to come back over to my calculator. Let me get out of here. Where is DMS? Degrees, minutes, seconds. Okay, it's this button right here between 9 and the catalog, right below delete. Okay. Remember, we want second row, second column. All right. So what was it? 3821? Is that right? Okay. And I believe, again, you don't have to plug in anything from seconds because there aren't any, but I'm going to go ahead and put 0 anyway. Minus, and now I'm going to do the same thing again. Okay. Now I believe this was 3020. Okay, so 3020, and then I'm going to plug in 0 again. Okay. So I'm going to take the difference of the 2 degrees, minutes, second values that I'm given. Now my calculator is going to give me 481/60, so control divide tells me I'm looking at about 8.02 degrees. Okay. But again, you said theta has to be in what? It's got to be in radians, so I have to convert it. Now, what we started doing on Tuesday, instead of converting it and then substituting in, I'm going to convert it as I substitute. Okay? And if you like to, convert it separately, please continue to do so. But the arc length I'm looking for is going to be the radius, 3,960, times the 8.02 degrees. But what's the conversion to make degrees radians? Pi over 180. So those degrees cancel. Okay. And you'll notice I'm not going to know what the radian measure is for my angle, and ultimately it really doesn't matter. I'm just wanting to know how far the cities are from each other. So let's see here, 3,960 times. Now, but I am going to go ahead and do this. I rounded on my paper to go ahead and show what it is that I'm doing, but I am going to go ahead and use the exact decimal value that the calculator provided because I want the most exact answer possible. Whoa, interesting. There we go. Okay, parentheses, and then I'm going to go ahead and multiply this by pi. Come on. Ooh, pretty. Pi over 180. Okay. So somebody help me out. What should I be getting when I push enter? How many miles? Okay. I'm getting 554.1. What'd you get, Will?
Oh, I said 534.
Oh.
But I just didn't read my own handwriting.
Okay. So about 554.1 miles. Okay. All right. Now what? 13? Okay. Okay, so 13 is a good one. Let me go ahead and kind of do a little review before we go ahead and get started. We've been talking the past couple of days about linear and angular velocity. So linear velocity is a speed. Okay, it's always going to be given in some length per unit of time. So miles per hour, feet per second, whatever it is. But Angular velocity, that's something different. That's the measure of the central angle, how fast it rotates with respect to time. Okay, so if linear velocity is always some length over time, how are we going to describe angular velocity? It's what over time? Not revolutions. It does start with an R though. Radians. It is radians per time. And these are the formulas that we've been using. For linear velocity, we have that V equals R times omega, the radius times the angular velocity. And remember, omega itself was equal to the change in theta over the change in time. Remember, we had that derivation the other day. I believe it was Tuesday that we actually did that. But there is another version of linear velocity that we looked at prior to getting this one here that we were using yesterday. We also know that linear velocity is equal to the distance divided by the time. You remember when I introduced the distance equals rate times time formula and we kind of equated the two? We just changed the variables depending on what we had. Well, the reason I go ahead and bring this one up is because the problem states it in such a way that that original formula is very useful to me. It says a car that has a wheel radius of 1.5 feet travels 30 miles in 45 minutes. How fast are the wheels spinning? Give your answer in revolutions per minute. So this one's kind of unique. We're starting off, given the linear velocity, we got to work backwards and figure out what the angular velocity is. Okay, so I'm going to go ahead and start with this because it says V equals, now I'm going to use this formula right here. Well, we know we're traveling 30 miles in 45 minutes. Okay, but do I need to change anything about this? What do you guys think? Well, we definitely can simplify, but that's not it. Do we need to change either of the units? Well, ultimately, we want to get to revolutions, but not quite yet. I'll tell you, we do need to change miles. Why feet?
Because of the rate.
There you go. Okay. I've got to convert this to feet per minute because my radius is given to me in feet. Okay, so I'm going to go ahead and tack on a ratio here. I want miles to cancel, feet up top. And this is one of those ratios that you'll probably use enough that you'll remember what it is. How many feet are in 1 mile? 5,280. Okay, so the miles are going to cancel, so I'm going to have the linear speed in feet per minute. Okay, so let's see what that is. 30 times 5280. Control divide, 30 times 5280. Divide that by 45. So 3520. Okay. So 3,520 feet per minute. Okay. Is everybody okay? So now that I have the speed using the same measurement as the radius, now I'm going to go here and I'm going to go ahead and try to figure out what the angular velocity is. So we found V to be 3520 feet in 1 minute. Okay, I was writing it out like we had before. Equals, what was the radius again? Okay, 1.5 feet. Okay, times omega. All right. Well, how would I figure out omega? Yeah, you just have to divide, right? But as soon as I divide, what happens? The feet are going to cancel. Okay, so I'm going to have 3520 divided by 1.5. So this is giving me 2346, let's say 0.7. 2346.7. So 2346.7, but what? Radians per minute. Okay. All right. So right now it is angular velocity. Remember, we solved for omega, angular velocity, which we just said is always radians per time. And the minutes didn't cancel. We kept those. Okay, but I can't help but think that this isn't the end. What's the question want? Remember, it wants revolutions per minute. Now, we have the per minute. So you remember every time we were solving angular velocity, We always took the number of revolutions over time times what? 2 pi radians over 1 revolution. So I'm going to use that same ratio, but I'm just going to flip it because the quantities are still equitable. So I'm going to multiply this by 1 revolution over 2 pi radians. Because what's going to happen? The radians are going to cancel. There's my revolutions per minute. Okay. So all I need to do is take that decimal and divide by 2 pi. So let's see here. Divided by parentheses, 2 pi, close parentheses. So I'm getting 373.5 revolutions per minute. Okay. How we doing? Had anybody solved 11 and 13 previously? Got the right answer? Okay. How many people attempted? My heart hurts. Okay. All right. Where are we going now? 12. Oh, I kind of feel like I'm doing all the hardest problems for you guys, though. Does anybody think they got the answer for number 12? Okay, Will, what'd you get?
I got 6.11.
That is fantastic. 6.11 inches. Did anybody else get that? Did anybody get close? How many people tried? Just raise your hands. Raise your hands. Oh my God, look at all those hands raised. Oh, at least we tried. Okay, awesome. Denial is not just a river in Egypt. Okay, let's move on. Oh, I work so hard. Let's go to 12. Okay, so since somebody did tell me the answer to that, I will go ahead and work number 12. All right. Now, remember, there are a variety of ways to work this. In fact, Mr. Yacht worked it separately from the way I did. Still got the same answer. So I'll just kind of walk you through what I did. It takes 12 identical pieces to form a circular track for a pair of toy electric race cars. Okay, if the inside arc of each piece is 3.2 inches shorter than the outside arc, what's the width of the track? Okay, well, this whole lesson is kind of revolving around arc length, area of a sector. So I kind of envisioned this section of track creating a sector. You know, we've all had these little tracks before, these curved little pieces like that. Okay, it takes 12 of those to go ahead and create one full circle. So I just kind of continued to draw and made a sector out of it. So what are we ultimately looking for? The width of the track, right? So I'm going to say that's the X I'm looking for. Okay. For the sector, I said that this full length is the radius. I said the length of the inside arc is S sub 1, and the length of the outside arc is S sub 2. Can anybody tell me what that measure of the angle for this sector is? 1/6 pi. How'd you get that?
Well, a circle is 2 pi. And
Yeah.
it's 12.
There you go. It takes 12 identical pieces to form the circular track, right? And he's absolutely right. Okay. 360 divided by 12 or 2 pi divided by 12. There we go. We're only looking for pi over 6 radians. Okay. Is everybody okay with that? Okay. All right. Well, what I did was I went ahead and created a couple of equations to help me out here. The first thing, I want you to see if you can create the two that I did. I want you to give me the arc length for S sub 1, and I want you to provide me an equation for the arc length of S sub 2 based on my diagram. Okay. So what does S sub 1 equal? What does S sub 2 equal? Now let's make sure we know what the form is. How do you find the arc length at all? It's the radius times what? Theta. Okay. So that's what I want you to do for each of those two arcs there. S sub 1 and S sub 2. And then let's all see if we can come to the same conclusion. Okay. So let's start with the easier of the two. Arc S sub 2. Okay. Well, what would this equal according to what I've drawn here? There you go. The radius for this larger sector I've just said is r, and we know what the central angle is. So it's just pi over 6r. Okay. But now the other one, I'm going to have to introduce a little expression for S sub 1. Okay. Remember, this is for the inside arc, the smaller sector. So what should I put here for the radius? Connor? Oh, not the 3.2. It would be r minus x. See, if the entire length is r, but I know this portion is x, then this remaining portion has to be r minus x. Now, we'll talk about the 3.2 in just a second. Okay, so I said r minus x times pi over 6. See, this represents the radius of the smaller sector, and then, of course, they still have the same central angle, pi over 6. Now, for that 3.2, all I did was take the second sentence, and I just actually translated it into a mathematical equation. If the inside arc of each piece, well, what am I calling the inside arc? S sub 1 is equals 3.2 inches shorter than the outside arc. Okay, S sub 2 minus 3.2. Okay. So I came up with these three equations based on the information that I was provided. Okay. And here's the thing. I went ahead and focused all my attention on the middle one. Okay. Why do you think I did that? Remember, what am I trying to solve for? I'm trying to solve for the width of the track, which I'm calling what? X. So I focused on that equation because it's the only one that has the x in it. Okay. So somehow these other two, I had to use those to help me out. Because if I'm trying to solve for x, well, I got to figure a way to get rid of r and s sub 1. And what I did was substitution. I solved this first one for r. Okay. If s sub 2 equals pi over 6r, what would r equal if I solve that? Close. Remember, you got a fractional coefficient, so what happens when you divide by that fraction? You multiply by the reciprocal. So I had 6 s sub 2 over pi. Is everybody okay? And then this one was already set up for me. So I just used straight substitution. I replaced r with that expression, and then I took this binomial and I plugged it in for s sub 1. Okay. Now let's see what that gives me. Instead of s sub 1 equals, I've now got s sub 2 minus 3.2 equals. Okay. Well, instead of r minus x, I'm going to have 6 s sub 2 over pi minus x times pi over 6. Okay. So there might be a few folks out there still thinking, well, that's great. You got rid of the r, but now I've got s sub 2's. Okay, but we're going to take care of those. What would you do next if I was trying to solve for x? Like, what would be the next logical step? What's that? I would distribute. Okay. So s sub 2 minus 3.2 equals, well, what would 6 s sub 2 over pi times pi over 6 give me? It's just s sub 2. Minus what? Oh? Minus pi over 6x, right? Okay. Now, why are the s sub 2's not a problem? They're going to cancel. If I try to move one variable over to the other to combine them, yeah, they're just going to cancel out. So now it's just down to a simple little equation. Negative 3.2 is equal to negative pi over 6x. And the fact that both sides are negative, I mean, I can just go ahead and make them positive. But I mean, even if I didn't, the two negatives would eventually what? They would cancel each other out anyway. So how can I get that pi over 6 to the other side? Okay, divide by, I can multiply through and then divide. I'm just going to take care of both at the same time. I'm going to multiply by the reciprocal. So that pi's cancel, 6's cancel. So it looks like 6 times 3.2 divided by pi. So let's see what I get here. Control divide. 6 times 3.2 divided by pi. Okay. And then there's my 6.11 that Will got in the beginning. So that's actually a pretty wide track. 6.11 inches. Okay. Did anybody else get that? Sandra, you got that? I'm sorry? You did? Why didn't you raise your hand a moment ago when I asked it? Oh, she goes, nah. Got to have confidence. Got to have, even if your answer isn't right, I mean, let's talk about why it isn't. Anybody get close? Anybody have a question? Okay. Right. Were we at least on the right track? You're the only class so far to actually respond to that one. Okay. I'll take a little giggle. All right. Where are we going to now? Will?
Can we go over the exit ticket?
You want to go over the exit ticket?
Yeah.
Sure. Okay.
That work.
Is everybody okay with that? I'm okay with that. Okay. You'll have to remind me of what it was. I don't have that in front of me. Like which problem?
Angles that measures.
Oh, I know the
yeah.
content, but what number?
Maybe number 1.
Okay. You were wanting to find a coterminal angle.
I don't remember.
What was the measure I gave you on number 1?
Theta 78 degrees.
78 degrees? Theta equals 78 degrees. Okay, so you wanted one positive and one negative?
Yeah.
Okay. So let's see what we got here. First off, okay, let's go over like what this means. What am I talking about when I say coterminal angles? An angle that ends at the same position. Okay, same spot. Okay. So angles that have different measures but will have the same terminal side. Okay, they stop in the exact same position. So here we're talking about 78 degrees, which would be in what quadrant? Definitely the first one, so probably something like this. Okay, let's say this is 78 degrees. Okay, so when I'm talking about one positive and one negative coterminal angle, all we're talking about is the direction we rotate full revolutions. Okay, like for example, let's go with the positive. If I were to start here, what do we call it when we start on the positive x-axis? What position? Standard position. So let's say I rotate here, but see if I stop, that's just 78 degrees, right? Okay. So I'm going to go one full revolution back around to where we were. Okay. So how would I determine that? How would I figure out the first positive? Yeah, just 78 plus 360. Okay. So 78 plus 360. So the first positive one would be 438. Okay. And that, see, here's the thing. How many times can I rotate? I can rotate an infinite number of times. So this one right here was 438 degrees, but then I could go another and then another. So all I'm going to keep doing is just continually adding 360 if I'm rotating counterclockwise. But now let's rotate clockwise. Let me go ahead and use another color for this. So this time I'm going to start here in standard position, but I'm going to rotate clockwise. Okay, now negative just tells me the direction. But how would I figure out the angle? What would I do with the 78? Just minus 360, because I'm going clockwise. So what is 78 minus 360? Negative 2 what? Negative 282. There we go. And then I could just continually go another one. and then another one. I mean, you could rotate. That's why we say there's an infinite number of coterminal angles. So that's what they mean. Angles that have different measures, but the same terminal side. Okay? Now what?
I thought it makes sense now.
Okay. Did you want me to give you another one?
I mean, I don't have another one.
Oh, I mean, I can just make one up.
Oh, I mean, I'm good now.
Oh, okay.
I know how to-
Okay. All right. Okay. So we want to go back to the homework? That's it? That's all the questions we had? Was just those last three? Okay. Yes, Fernando. 5 or 6. Okay. All right. Which one do you guys prefer, 5 or 6? 5. Let's do 5. But let's also do this, because I've worked several of the problems here. Why don't we get somebody up here to help me out with this one? Okay. Who wants to come on up and help me? All right. Galen, thank you very much. Well, that's okay. That's okay. But you already raised your hand. Come on. What's the worst that can happen? What did you think I was talking about? Oh, okay. Okay. Would you like the?
No, okay.
No? Or at least say hello.
Hi.
Okay. Okay. So we're doing number 5, where it wants me to find the arc length and the area of that sector. Round to 3 decimal places. She said I'm scared and she's walking away. Okay. Okay, so you got this. You got this. Okay. All right, so Galen, let's start with the arc length. What does S equal? Radius times theta. So do we have the radius?
Yes.
Okay. So S equals the radius times theta. You want me to lower this one?
Yeah.
Okay. I would have said something, but I didn't want her to get short with it.
Oh no. Okay. And then theta is. Isn't it just 2?
And theta is already in radians, 2 pi over 3.
That's an ugly pie. Okay.
Okay. So now that would be 4 pi over what? 3. Okay, let's just type that in. So let me document B this out of here for you. Control divide. Okay.
I don't know what it was.
4 pi over 3.
Oh, okay.
Oh, and I think it's because I used that green. So okay, I'll go ahead and type it in. Let me go ahead and get rid of that first. Delete.
Stop laughing.
Okay, so 4. Oh, Dad, come on.
It really is.
Pi. Let me go ahead and put in the 4 over 3. So 4 point. Now, how many decimal places did it want? 3. So I would say 4 point what? Okay, so 4.189 what?
Radiance.
Oh, not radians.
Oh.
Because remember, we're finding arc length. So what was our radius given?
Oh.
Feet. There we go. So that's our arc length.
Yay.
Okay. And now we just need the area of the sector. Yay.
Wait, do I have to do the area sector for this one or that?
For the same one. For you need to do both for 5 and 6. Okay. And I'll tell you what, while she's doing that, if you have your homework ready to go, let's go ahead and pass that up to the front. Okay. If you need to, if you want to turn in your focus activities, that's fine as well. I do have a stapler here. Okay. But I notice we're down to a couple of minutes, so I don't want to, run out of time. Okay, so she is right. 1/2 the radius squared times theta. So 1/2 2 squared times 2 theta.
Same thing.
So this one's actually pretty interesting. The arc length on number 5 also turned out to be the area of the sector. Oh, but it's feet
No.
squared. There we go. Thank you, Gant. See, that wasn't so bad, right?
Yeah.
There you go. Okay. All right, good. Good, good, good.
Okay.